All right, today we're going to be doing this sliding window question, number 239 on LeetCode, sliding window maximum, right? So what's going on with this question in particular is you're given an array called nums, right, and k. So what we need to do is taking a look at nums, right, and k, we need to find the largest values starting from 0 to k. So visually, right, you have k over here, which equals 3, right? And this array is our nums, right? So we need to make sure looking at values 0 to 3, right? 1, 2, 3. The highest number out of all this is 3, right? And then you keep on pushing, right? 3, -1, -3. 3 is still the highest, so you point at it again, right? And you basically keep this game up all the way. You see 5 is the highest, so we have 3, 3, 5, and you keep on pushing. 5 is still the greatest again. 5, right? 6 is now the greatest. 6, do it one more time. Out of all these three, 7 is the greatest, and this would be your answer that you're trying to return, right? So now as we have an idea of what we're looking for and how we're going to get it, now it's time to implement that, right? So one of the first things we need to do is get our length, right? So we're going to make a length variable and set it equal to the length of nums, right? Then we're going to make a variable called result. This is where we're going to store all those values that we were just doing. And then we are going to call dq equals dq. So dq is basically a data structure. Think of it kind of like as a queue, but you're able to add values from the front and end, as well as remove values from the end and front, right? So you know with the queue how you could do like dot pop and remove the value from the end. You could also do that for the beginning and so on, right? So this is really important. And then we're going to make two pointers. We're going to make left equals 0 and right equals 0, right? So what's happening with these two is right is basically going to always be moving, right? So they both start, at 0, left and right. And right is going to continue moving, right, over and over. And once right reaches a certain point, then we'll move left. But the key point from this is right is basically the value that will reach the end. So that's what we're looking for. So with that in mind, right, we should probably make a while loop. While right is less than length, right, we're basically going to be doing everything in here. So with all this stuff being made, all the code now has to be in the while loop. One of the first things we're going to do is do another while loop within, right? So while dq. So this line means, okay, if there is something in dq, then we're going to write and nums at index right is less than, is greater than or equal to nums at index dq 0 or -1. There you go. And you're going to do dq dot pop, right? So what's going on here? We're still writing the rest of the code, but basically what's going on is within this while loop, you are checking A, if there are values in dq, right, which we are going to continuously be adding values within there. And then we're also checking if nums at index right, which you do know now that right will always be continuing. So when you make a for loop, like kind of like for x in or for x in range, like right is basically going to be that, right? It's going to be that pointer. So if nums at index right is greater than, this is supposed to be equal to, nums at dq -1, right? So we're looking at nums, right? And at index dq -1. Well, our dq -1 is basically the last value within. So we're looking at the last value and we're saying, okay, if the number we're on right now is greater than that, we're just going to continue removing the values from DQ until our value is basically all the way in the beginning. The reason for this is because we want the max value, like the highest value that we can get, all the way in the beginning. Because we're going to be grabbing that number from the beginning and adding it to result. Because remember, we're trying to find the maximum, right? What this is doing is basically putting the maximum value in front of DQ. Okay. And then once all this is done and we're done popping, then of course we need to add the value into DQ, right? So DQ.append, right. There you go. So this is, we will say helping putting maximum value in front, and then this will be actually putting the value into DQ, right? Then we need to, we're going to be moving left, right? So this will just be a simple if statement, but remember that the values need to be from 0 to k, right? So if k is equal to 3, then they need to be, in increments of 3. So you see where I'm highlighting 1, 3, -1. Then the next one be 3, -1, -3, right? We need to make sure that it stays in that range. So we're going to make an if statement. If DQ, or let's see, if DQ at index 0 is less than left, right? We're going to DQ.pop left, right? Okay, so what's happening here in this line is that remember that all the values that we're adding into DQ are the indexes, right? So right and left, those pointers are supposed to represent indexes, which is why you see us doing things like this. Nums at index DQ -1, right? We are grabbing the index and plugging into nums to try to see the actual value. So if DQ at 0, right, which is our first value in DQ all the way in the beginning, if it's less than left, which left will increment at a certain point, I'm going to write that next, right? Then we want to remove that that first value, so we kind of stay in the ranges from like 0 to 3. So this is just making sure we always have values 0 through k, right? Then we're going to do another if statement, and this is the main one, right? If right plus 1 is greater than or equal to k, right? So this statement is saying, okay, so we're incrementing right over and over and over again, which I'm about to write that near the end. But we're going to be incrementing this over and over again, right? And if right plus 1 is greater than or equal to k, which k is 3, right? So once we kind of reach that point where, okay, like we now have like 3 values in our window, then we need to make sure that we do the usual sliding window stuff, which is remove the value from the first index, right, and add the next one. So we're going to do, first thing we're going to do is answer data, or not answer, results dot append nums at index DQ 0, right? So this is basically saying, okay, we have 3 values now, right? Because we've looked at 3 values, then we're ready to kind of add the first answer. So we would be running this if statement once we've kind of reached 1, 3, and -1. These are 3 values, right? And within this little section of like the 3 iterations we went to, 3 is the highest number and should be all the way to the left, right? Thanks to this right here, this line. So when we do result.append DQ at 0, right, 0 is the beginning of DQ list. The value in the beginning DQ list should be the most maximum number we've seen. So result.append will have 3 in it now, right? And then you will do left plus equals 1, right? Because now at this point it's like, okay, so now as we kind of seen 3 values, we need to start incrementing left, right? So we could start grabbing 3 and 3 and 3 and continue going until we reach the end of the loop, right? And then, like I mentioned over and over again, right will always be incrementing by 1, right? So this line right here is going to be kind of helping us run through all this other stuff. And then we can just return result. And then if I was to run this, yes, perfect, it does work. So that's to show that it does work. To show visually how things will work, we're going to be using this thing called Python Tutor. It's super helpful. But this is basically our code, and all I've done is kind of initiate the function so we can kind of see step by step. So let's get to the beginning. Okay. So you have length equals 8 right here, result, which is an empty array as in the moment, and DQ, which is just an empty DQ, right? And then you have left and right both equal 0. You see how all the variables are down here. While right is less than length. Right and length, okay? So right is here and length is 8. So because this is true, we continue the loop. While DQ, right, which first this saying if there's anything in DQ, there's nothing. So we're going to skip this. And we're just going to add something to DQ, which is right. So just 0, right? If DQ index 0, right, is less than left, which DQ at index 0 is less than left. Left is right here, right? So we're just going to skip that because that's not happening. If right plus 1 is greater than or equal to k, that's not happening. So we just do right plus equals 1. So now right is 1, DQ has 0, and we've only done 2 things. And you could see all these are while loops, right? If statements, like these are condition based. So the 2 things that are happening always is step 2 right here and the right incrementing by 1, which we just saw live. So now we go and do it again. While right is less than length, right is 1, length is 8. This is true, so we continue. While DQ, is there a value inside DQ? Yes, there is, 0, right? So now we could check if nums at index right, this is nums, this list right here, index right is 1, right? So if nums at index right, 3, is greater than nums at index DQ minus 1. So basically the last value of DQ. DQ only has 1 value, so the last value will be 0, right? And it's at nums index DQ minus 1. If DQ is 0, then nums at index 0 is 1. Is 3 greater than 1? Yes. So you're going to pop this, right? So you see how we pop it, and now there's nothing in DQ right now. Then we do DQ.append, right? So now we're going to append right. And right is 1, index 1, right? Remember how I said left and right are represented by indexes? So we're going to add 3, or we're going to add 1 into DQ, and there it is, right? So we're doing this to make sure that the highest value is always in the beginning. So we're going to just continue doing this one more time, right? So if DQ and index left, right, we're going to skip this. If right plus 1, we're going to skip this because we haven't seen this yet, and then just right plus or equals 1, so now right is at 2. So we continue doing this one more time. While right is less than length, right is 2, length is 8, so we continue. While DQ, so if there's something in DQ, which there is, and nums at index right is -1, right, is greater than nums at nums at index DQ minus 1. Like I mentioned, there's only one thing in DQ. -1 is supposed to represent the last value in a list. There's only one value, so this will just be 1. If nums at index 1, which is 3, right? 1 is here. If num's at index 1, 3, is that less than num's at index right, which is -1? It's not. So we are not going to pop anything. Instead, we're just going to add dq.append right. So you could see how now we have two values in dq. And 1 is still the highest value. That's why it's all the way to the left, right? So then we go here. If right plus 1 is greater than or equal to k, right? Right is 2 plus 1 is 3. Is 3 greater than or equal to k? 3 is equal to k, right? So what we're going to do is result.append nums at dq 0, right? 0 is the beginning. The beginning value of your dq will always be the highest. You see how out of these 3 in nums, 3 is the highest value, and 3 is in index 1. So that's why the 1 is here. We are right now appending that number, 3, into the empty result. So result.append, which is now why we have 3 here, and we're going to increment left by 1 and right by 1, right? So the left, right we've been always doing, left is the new thing now, right? Okay, so now you have left is increment at 1 and right is at 3, right? So we're basically here now. Like I mentioned, right is always going. And you're going to continue going this on and on and on until we finally reach 7. But with that being said, that kind of visually shows you how that's supposed to look. And if I submit this, I believe, let's see, perfect, yeah, there you go.